In this video, we're learning how to find the average value of a function on a closed interval. We'll start with the definition, see how to derive the formula, and talk about what it represents geometrically. We'll then walk through several examples so you can see exactly how to apply the formula to different types of functions. Be sure to download the free guided notes to follow along, highlight the formulas, and work through the examples with me. We're going to start by learning what the average value of a function is and then go over its formula. The average value of a function, such as the function y is equal to f of x shown here, is just a number, such as this number right here, that represents the overall behavior of a function on an interval. In this graph, our interval is from x is equal to a to x is equal to b. To find what this number is, we're going to look at the area under the curve y is equal to f of x, which is this area right here. This area is the sum of an infinite number of rectangles under our curve that have a height of f of x sub I and a width of delta x. The sum of all these rectangles is equal to the integral from a to b of our function f of x dx. To find the average value, it's easiest if we write out all the terms in our sum like this, and then substitute in that delta x is b minus a over n. If we rearrange the terms and bring the n under the sum of all of our function values, we can see that the terms on the left are the average of the function values. And on the right, we have 1 divided by b minus a times our integral that's equal to the area. Now we can talk about the formula. The average value shown down here of an integrable function f on a closed interval from a to b is 1 divided by b minus a times the integral from a to b of our function f of x dx. And we can abbreviate the average value by f sub av. Looking at this graph below, we can see that the average value of our function is just the height of the rectangle that has the same area as the area under the curve y is equal to f of x. We're going to walk through two examples where we're going to find the average value of a given function on a closed interval. Let's look at our first example. Our function is f of x is equal to sine x, and the closed interval is from 0 to pi. Just to make things easier, over here on the right, I have written down the formula for the average value of a function on a closed interval. We're going to start by writing down this formula. Our average value AV is 1 all divided by b minus a of the integral from a to b of f of x dx. I think the hardest part of doing these problems is just remembering that formula. Let's go ahead and let's put in what b and a are. B is pi and a is 0. So we have the integral from 0 to pi, and we substitute in that f of x is sine x. And then we can just go ahead and integrate this. This is 1 over pi. The integral of sine x is minus cosine x. And we're going to evaluate this for x is equal to 0 to x is equal to pi. This gives us 1 over pi minus cosine pi minus a negative, so that's plus cosine of 0. You really have to watch your negatives with this problem. Cosine of pi is negative 1, so this is minus a negative 1, which gives us a positive 1, and then cosine of 0 is 1, so we get an answer of 2 divided by pi. This is approximately 0 0.637. So we have an exact answer and an approximate answer. We can understand our answer better by looking at this graph down here on the right. The blue curve is the function f of x is equal to sine x from x is 0 to x is pi, and the green line is our average value, which is equal to 2 divided by pi. Let's now look at our second example. We're given f of x is equal to 2x cubed minus 6x squared, and our closed interval is from -1 to 2. Let's write down our formula. The average value of a function on a closed interval is 1, all divided by b minus a, times the integral from a to b of f of x dx. If you write down the formula every time you do a problem, it'll make the formula easier to remember. Now let's plug in that b is 2 and a is -1. So this is 2 minus a -1. We have the integral from -1 to 2, and the function that we're integrating is 2x cubed minus 6x squared dx. This is equal to 1/3 the integral from -1 to 2, and we have 2x cubed minus 6x squared dx. Let's now go ahead and let's integrate this. Our first term integrated is 2x to the 4th divided by 4, and then we have a minus 6x cubed divided by 3, and we're evaluating this from x is equal to -1 to 2. Let's go ahead and simplify what's in our parentheses before we substitute in -1 and 2. We have x to the 4th over 2 minus 2x cubed. And we're going from x is -1 to x is 2. This gives us 1/3. 2 to the 4th is 16, so we have 16 over 2. Minus 2 times 2 cubed, which is 8. And then we subtract off. Let's put a parenthesis here so we remember to carry that negative through to both terms. We have -1 to the 4th, so that's just 1. So we have 1/2 minus 2, and then -1 cubed is -1. So we have a lot of negatives here to watch out for. Let's see what we get. This is going to be 8 minus 16 minus 1/2. Here we have a 2, and then we have a minus out in front, so this becomes -2. This then is 1/3. 8 minus 18, so that's -10 minus 1/2. This is 1/3. We get a common denominator of 2. We get a -21 over 2. So our final answer is -7/2. And that is equal to -3.5. If we look at our graph over here on the left, in blue, I graphed the function that we're trying to find the average value of. It goes between -1 and 2. And then we found that the average value was -3.5, which is represented by that line right there. And you can see that graphically, it represents the average value of our function. And that's it. You've learned how to calculate the average value of a function on a closed interval. To really master this concept, make sure to work through some practice problems on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.